Runout refers to the deviation from true circularity or concentricity in a rotating object, typically a shaft or a cylindrical part. It is a measure of how much an object wobbles or deviates from its ideal axis of rotation. Runout is caused by a bent shaft or by eccentricity of the coupling. Eccentricity means to be off-center. It can occur if the coupling is not bored in its physical center, or if the bore is bigger than the shaft and the set screws pull the coupling out of center. A dial indicator, or the ACOM runout probe, can be used to measure runout. The runout probe is a digital version of a dial indicator which connects to the pre-alignment application and calculates total runout. The runout probe is what we will use in this video for demonstration purposes. When measuring runout, the probe base should be mounted to a fixed point, such as the base of the machine or any other fixed position. We recommend that you first check for runout at the hub or the rim of the coupling, because there you will pick up both eccentricity and bent shaft. Some people will also measure runout in the axial direction, which in addition would tell you if the coupling bore is skewed. Before taking the readings, make sure the plunger is mounted perpendicular to the shaft. The plunger can both expand and contract, recording negative and positive values. These values correlate to the high and low spots on the shaft. For this reason, when mounting the probe, it is important to set the plunger to half its specified travel range. This assures the probe can measure its full capacity in both positive and negative directions. Once the probe is affixed, rotate the shafts. It is best to rotate in only one direction. As the shaft rotates, the probe determines the total amount of runout. The pre-alignment application takes the difference of the minimum and maximum values to calculate the total runout present. If the runout is within acceptable limits at the hub, usually 2 thou or less, then the coupling must be bored properly and the shaft is reasonably straight and within acceptable limits. In this case, the probe is indicating excessive runout of 22 thou. When excessive runout is observed, we next need to determine if it is being caused by a bent shaft, an eccentric coupling, or both. We achieve this by repeating the same measurement process at the shaft. You'll want to take the measurement as close to the coupling as possible. In this case, there is 21 thou of runout at the shaft, accounting for most of the 22 thou of runout we observed at the coupling. Therefore, the bent shaft is the problem. If our measurement at the shaft had been close to 0, the problem would have been the eccentricity of the coupling. Of course, we could observe a situation where both conditions occur, a bent shaft and an eccentric coupling. If excessive runout is present, it should be corrected before attempting precision shaft alignment.